Va bene, dove vuoi? Dove riesci?
Non ho veramente una sì, dove riesco.
Google mi dice che tutto è sempre autonomo. Ho fatto partire lo streaming.
Ok.
Io la notifico. Poi io la notifico.
Non è fatto.
Io mi sono iscritto a fare un pannello tutto. Va bene. A me non mi sembra suonare.
Ti serve una mano?
Credo che... Boh.
Sì, sì, sì.
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 Ok. Funziona.
Per far vedere un page. Sarà che non è un zero.
L'audio del computer che arriva anche.
In teoria sì. Non ho fatto questa prova.
Però tu lo puoi vedere se ti arriva questo sito adesso riproduce qualcosa. Però esce
Perfetto. Ciao a tutti.
Vai.
Urlo. Ciao a tutti, siamo qui nell'ultimo appuntamento indoor della stagione per Bologna JS. Io sono Edoardo e ringraziamo le persone che sono venute qui, un po' poche perché c'è la bella stagione, ma ecco, hanno suonato. Apri! E niente, chi siamo noi? Siamo Bologna JS e siamo allo spazio 01. Allora, noi siamo la community del JS e ormai si dice anche TS. Siamo amici ma anche devs. Che cosa facciamo? Tante cose. Ci riuniamo da ormai qualche anno. Abbiamo fatto del talk, abbiamo fatto dei workshop all'aperto, ci siamo incontrati per fare delle cene e siamo molto attivi nel nostro Slack, più o meno. E se volete iscrivervi al nostro Slack, bolognags.com, poi cliccate nel micro link che c'è al centro Slack e vi potete autoinviare un invito se volete fare due chiacchiere sull'informatica, il mondo della programmazione o volete provare a risolvere qualche vostro problema, ci potete scrivere, o se volete fare parte della nostra community, insomma entrate, lo Slack è il punto di contatto e poi scoprirete tutte le cose che facciamo. Vi potete anche scrivere al nostro meetup, meetup.com, cercate Bologna JS, dove mandiamo la mail quando creiamo l'evento e dove ci scriviamo, perché generalmente, ve lo giuro, che dobbiamo limitare i posti molto spesso. Oggi li abbiamo limitati a 100, sono venuti in 90, sono iscritti in 99, quindi silenzio laggiù per favore. Poi che abbiamo scritto qui? Siamo inclusivi, c'è lo sbirro dell'inclusività che sono io, tutti possono essere coinvolti, nessuna domanda è stupida, junior, senior, io sono junior in Java, Stefano è junior in JS e così via. Siamo tutti impostori. Poi, che ci abbiamo messo qua? I nostri partner. Ringraziamo Spazio 01 che ci offre lo spazio 01 per fare questi eventi, soprattutto quelli invernali, perché dicevo che l'ultimo evento indoor, dopo ci incontriamo qualche volta, a volte neanche facendo il meetup, ma direttamente accordandoci sullo Slack, ci vediamo alle Serre dei Giardini o nel parco 11 settembre, che l'ho detto adesso, non è vero, però ciao, benvenuto. E poi ringraziamo TrueScreen, che è un'applicazione creata dai ragazzi di Spazio 01 molto figa, l'avrete letta in questi giorni dopo l'alluvione sul Carlino, l'avrete conosciuta, se non la conoscete cercatela, è un'applicazione che serve a verificare non ve lo so spiegare, serve a certificare le immagini e i video, e a questo punto anche l'audio, e hanno un valore anche legale. Per esempio conosco degli avvocati che la utilizzano, oppure se uno vi mena riprendetelo, ci passate subito TrueScreen sopra e dopo lo portate dal giudice e vi fate dare i soldini. E Bitcode invece è sempre l'azienda che lavora dentro Spazio 01, insomma dei ragazzi di Spazio 01, e fanno app. Poi ringraziamo anche il GRUSP, siamo partner del JS Day, del React Day, ci danno dei biglietti per seguire in remoto gratuitamente le loro conferenze, li conosciamo da tanti anni, sono fighi, ci piacciono. La tua azienda, se avete un'azienda e volete sponsorizzarci, noi non abbiamo associazione, non abbiamo niente, ma accettiamo sponsorizzazioni, metterci a disposizione uno spazio, regalarmi un Mac, cose così, tranquille, pagarci una birra e mandare, ecco, una bella sponsorizzazione che dico sempre è pagare qualcuno della vostra azienda, cioè, faccio l'esempio personale, la mia azienda mi fa preparare un talk durante l'ora di lavoro e poi ci mettiamo qua il loro bel logo. Poi il talk di oggi, mi ero preparato una domanda, chi è che viene per la prima volta a Bologna JS? Tu no? Laggiù ci sono voi non lo vedete, ma laggiù c'è tanta gente che ha alzato la mano. Allora, oggi, il talk di oggi, web audio fare rumore con JS di Alejandro qui presente, che poi vi presenterò, anzi ora vi presenterò e conoscerete. E è una bella storia secondo me, perché parliamo anche di audio, in genere parliamo solo di JavaScript, informatica, è bello diciamo unire un po' l'aspetto informatico all'aspetto della musica. Allora, poi ho quasi finito con le mie cavolate. Dopo l'evento ci fermiamo per una cena, chi non ha 2 figli, di cui uno piccolo magari, e andiamo spesso al supermercato delle erbe o ci facciamo un aperitivo, insomma è molto importante anche il momento della cena, perché si fa 2 chiacchiere, si fa 2 risate e ognuno ci racconta qualche bell'aneddoto. Allora, dopo il talk di Alejandro estrarremo 2 licenze di JetBrains, perché uno dei nostri partner, che non c'era nella pagina di partner, porca miseria, è JetBrains, che ci fornisce 2 licenze per ogni evento che facciamo, che andiamo a estrarre. Quindi alla fine dell'evento facciamo una simpatica lotteria, sempre creata dal nostro Giorgio, e con una bella ruota colorata che gira, e vi aggiudicherete 2 licenze di JetBrains che hanno 1 milione di prodotti, sono super fighi anche loro. Dunque, si parte, vi lascio ad Alejandro, stacco il mio computer, gli rendo il microfono.
Allora, magari posso lasciare anche nella tavola il microfono? Ci si mette meglio? Okay.
Grazie.
Farò magari un po'.
Bravo!
Prima di cominciare devo solo vedere se l'audio è correttamente messo.
Domande alla fine o ti possiamo interrompere?
Possiamo interrompere, non c'è problema. Ok, prima di cominciare devo dire che sfortunatamente il mio italiano non è molto buono, quindi non posso fare questo talk in italiano, mi dispiace. Sono arrivato da 4 mesi più o meno, ma vi prometto che continuerò a imparare l'italiano e magari per la prossima volta riesco a fare un talk intero in italiano, che mi piacerebbe tanto. Ma mi dispiace tanto, questa volta sarà in inglese, soprattutto perché i termini tecnici non riesco. Okay, so I'm going to switch to English. I'm very sorry. And today's talk is going to be about web audio. So just like a quick show of hands, how many of you are musicians or DJs or something related, or have done something related with music? More or less? Okay, perfect. And how many of you have used web audio before? Okay, perfect, we have one. Okay, so before we start, if I manage to click here, my name is Alejandro, and you can find me under GitHub or pretty much all social networks and stuff under the moniker alemangui. I'm a software developer for more than 10 years, more or less, mostly web. I did several years as a native app developer as well. Right now, I work as a freelance developer for the French government, and before then, I was in mobile development for American Express, and I did a bunch of other little jobs and companies before. And one of my hobbies, like a side hobby, has always been music. I like it very much. So when I started investigating several years ago about web audio and everything, it kind of caught my attention as a way to kind of put together the two passions, let's say. So, okay, before we start, why should we learn web audio? So I'm going to give you a few use cases before we get into the meat of the subject. So let's say that the case 0 is the applications like Slack or Hangouts or Skype that have certain sounds that correspond to certain use cases. So for example, the little blips when there's a message or a call coming in or something like that. There are things that from a UX perspective are necessary to show what the application is doing, especially if there's audio related, right? But this is very basic, so it's just playing audio. And the audio tag is potentially good enough, let's say, to do it. You don't need like a whole API of audio synthesis. But still, it's, one very little case. If we start climbing a little bit in the complexity, let's say, of the audio implementations, we quickly get to like the multimedia thing, like gaming. So for example, let's say that you're doing a clone or a game kind of like Zelda, like the old Zelda, right? So you have like the sound of the sword that when you click, cling, something like that, right? So sound is very important for the immersion in multimedia. And maybe what you want is that when you play that sound inside a room, that you get some reverb, for example. So when the sword sounds, you get some reverb from the room. Or maybe if you hit a tree, since it is wood, you want the sound to be a little bit different. You want like a cling sound, like a crisp sound. You maybe want to filter the high frequency so it's more like a thing, Or perhaps you can even add it as a way of involving the storytelling of the game. For example, if you hit a wall that is hollow behind, you may want to add an echo to the sound, for instance, so that you know that you can put a bomb and open a new chamber or something. So you could have like 20 different sound files for the sword, or you could just have the sound file for the sword, and with web audio, do the filtering of the frequencies, add the echoes, add the reverb and everything, and that way you get much more, like a much richer possibilities with way lower performance penalties, let's say. But you can even go beyond that, and you can create like full-fledged digital audio workstations in which you can compose, you can do DJ stuff, mixing music, you can crop segments of audio, put them together, pan things left and right. This screenshot here is actually a browser-based digital audio workstation that's called BandLab, and they managed to like you can proper do songs and compose and mix and add effects and everything there. So that is actually pretty impressive because, again, there is no backend processing. Everything is done on the client side in the browser, which is kind of a little bit crazy. So in order to understand how web audio works, we need to have a little history lesson from 50 years back, because it's still kind of the way that it started, the way that it still works today. So for example, this is 50 years ago, okay? These photos are from a workshop in London in the BBC, around, I don't know, maybe the 50s or the 60s. And these people, this is, by the way, little parenthesis, this woman is called Daphne Oram, and is one of the pioneers of electronic music. It's like a whole, she's incredible. You can find her Wikipedia page. It's amazing what she has done. But anyway, they were in a BBC workshop, and they were tasked with creating sounds. So for example, have you seen Doctor Who, more or less? Well, these kind of things of the BBC, sometimes the characters needed sounds. Like if there was a robot, they needed a bleep, bleep, bleep sound or something like that. Or they needed an ovni sound. But there were no computers back then, so they couldn't just go and do the thing, They had to physically create the sound, which is crazy. So they had these huge workshops in which they had audio inputs, like that little piano or a microphone or something. And the signal went through the cable and passed through many different little boxes, and each box did some modification of the sound. So for example, maybe they started with a note, like a ding, and then it passed through here, and they modulated the thing, so it was like ding, and then little by little, they started going one by one by one by one, doing a graph of little nodes, let's say. And at the end, when they were happy with the sound, and they were like, yeah, this is the sound for our TV series or our radio series, they would record it, and then they would have the cassette. I really like this image because here Daphne is actually drawing by hand an audio wave, which is crazy. So actually the input is as a drawing of the wave that goes through this machine, which reads it, and then it starts the wave. So it was crazy. Once they were like, yeah, okay, after, I don't know, weeks of work, they find the little noise of the robot, okay? So they did a graph to describe how you could get to that sound. So for instance, in this graph, they say like, okay, you need an input that has to go to an amplifier that will amplify the signal. Then it has to go to a splitter that would remove the signal in two, and you have a tape machine that is also an input, you have a signal generator. And this was kind of like the code to generate the sound. I really like this one because there is an echo room, which is an actual physical room like this, that has a microphone and a speaker. So again, there were no computers back then, so they like, actually had to have a microphone here and a speaker there, and that was the echo room that added the effect. And this is the way web audio works still today. So to learn web audio, you only need to learn kind of 3 concepts. The first is the audio context, which is your studio. So basically your studio in the browser is called the audio context. And it has one property called the destination, which is the audio output of the computer. That is the audio context. Inside your audio context, your studio, you have nodes. And the nodes represent basically all those little boxes, the room with the echo, everything. And basically nodes can do 3 things. They can create sound, like Daphne with this drawing of the sign. It can modify sound, like the amplifier that will boost the volume, for example, or the echo room that will add an echo. Or it can analyze it. And the analyzing of the sound just means that you can see the wave, or you can get information on the sound wave that is passing through. And the last object is the parameters. So the parameters just means things you use to configure the nodes. So for example, the amplifier has a parameter of the gain, how much you want to amplify the signal, for instance. Or the signal generator has a parameter of the frequency of the signal that you want generated, for example, right? The echo room has the size and the position of the elements, all of these things. So those are the parameters. And that's it. Those are the 3 objects of web audio, period. So now that we know this, how does it look in the actual browser? So we're going to try to do some stuff. Maybe it will not work, and I will be very sorry, but we're going to try. Okay. So if I open a tab, and I open, whatever, here. If it's small, I'm going to try to make it bigger. Can you see here? Yeah. Okay. So, like I said, first we need to see if the audio works. It works. So first we need to create our studio, right? The context. So we like context equals new audio context. So this is we have in this context thing the whole studio. Now we're going to create one node that generates a signal, and we're going to connect it directly to the destination. So it's going to be the simplest possible audio graph in the world. So the oscillator is going to be a context.create oscillator. So we have an oscillator that will create a sine wave. We can see what the frequency is, for instance. The frequency is 440, which is an A sound. And now all we need to do is oscillator.connect context.destination. So the oscillator is connected to the destination. And see what happens when we start the oscillator. Okay, I want to mute it because it's not very pretty. But that sound was actually generated by the browser. And now we can stop it too. Okay, so that worked. Now, there are some things that are a little bit annoying. So for example, if I want to start that thing again, and I say, okay, start again, this beautiful sound, boom, error. And this is because all of the nodes in web audio are single use, or most of the nodes are single use. So for performance reasons, the implementation is that once you use it, it's dead, which is super annoying, but that's the way it happens. And so you need to have, depending on the implementation on the browser, you need to be a little bit careful that you disconnect the node so that it can be garbage collected. Otherwise, it will remain in your graph. So you say like, okay, oscillator.disconnect. And that way it's disconnected, it's an empty thing, so it will probably die at some point. And if you want to create another sound, you have to do another one. So again, context.create oscillator, and you need to connect it again to the context.destination. And this time, you can do, for example, let's change the frequency so that it's not the same sound. So we're gonna put it a little bit lower, 220. So, oops, sorry, I did that for the original oscillator. So oscillator 2. So oscillator.start, we have a lower sound. And we could have it a bit higher. Okay, questo è typo, thank you. Okay, now it stops. So anyway, this is basically the most basic graph in the world, just one audio creation thing and one destination, and that's it. So it worked on my machine. That is kind of nice. But the thing is that we have many nodes. So the one that we use right now is the oscillator node here, but there's like a gajillion. So for example, the buffer source node over there is used to, when you have, for example, a file, an audio file, an MP3, and you wanted to load it, you put it in the buffer thing, and the buffer node will start rolling it out as buffer pieces. So that one's used for audio files. You have a bunch of, like, for example, delay node, all of those are for modification, etc. So actually, what I propose is that we're gonna not see all of them because otherwise we will be here all night. But we're gonna see like one for generation, which was the oscillator. We're gonna also try to see how the modification worked. And then we're also going to see the analyzer node, the first one over there, which is the one that analyzes it. And that way, like there's like a general idea, and the other ones kind of follow the same principle, let's say. So anyway, let's try now the audio modification nodes. So again, there are several. There's the delay, the dynamic compressor. The compressor basically will compress the peaks of the audio wave. For example, the panner node will go left and right in the channels, etc. No? So the way that the delay node works is, I was very naive when I started because I thought naively in my head that the delay node will give me a beautiful echo sound, and no, it really just delays the sign, that's it. So for example, if I come here, I'm gonna create another oscillator on the same variable name. Sorry about that. No, actually, I'm gonna be a little bit cleaner. Context.create oscillator. So create an oscillator again, and this time we'll create a delay node. So delay context.create delay. And the way we're gonna do it is that, actually, I think delay.delayTime.value, we're gonna put 2 seconds, let's say. I'm gonna connect the oscillator to the delay, and the delay to the speakers. So we do something like oscillator3.connect to the delay, and the delay.connect to the context.destination. So normally, unless there's a demo effect, the oscillator 3 will start, but we will not hear the sound until after the delay node decided to let it through. So if I do oscillator, do I have sound, by the way? Yes. Oscillator 3.start. So there was a little space, and then it started. And if I stop it, again, it will not stop immediately. It has that little echo thing. So it's nice because it works, but again, in order to do an actual real echo effect, it's not that simple because this is like very basic Lego blocks in which you need to add a bunch of Lego blocks and a lot of connections to do anything that is a little bit nice. So what happens if I started playing around and I was like, okay, how do I do an actual echo, like a dun 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 dun. And then like I came up with, well, I didn't invent this, but like there's a lot of research papers and things which show how to create effects. So this is, for example, an actual echo thing in which you have the input, then you have a delay node that goes to a gain node. So here they start ping-ponging, like dun, 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 dun. And then you have like the volume for the effect and the volume for the dry signal, and then the output. So this is more like this thing that I expected, let's say, when I started, and then that I realized that actually that's not the way it works, but it was fine. And finally, I wanted to talk a little bit about the analyzer node. Now, the analyzer node is a little bit complicated because we're going to have a little math reminder. Because basically, okay, let's assume the analyzer node works and is very useful if you want to create visualizations. So for example, if you want to do an equalizer thing, or if you are doing an application in which you see the actual sound wave, like for example in WhatsApp when you get a voice message, you see the little thing, so kind of like that. That is the analyzer. But first, little parenthesis. Do you know why, if you have, for example, an A note with the oscillator, like the tune, and if you listen to an A note on a piano, or if you listen an A note on a violin, even if it's the same note, you can know that it's a different instrument, right? And this is because they create different waves. So for example, this is called a pure wave. It's pure. It's really a completely sinusoidal wave. So that is what we have been listening to so far. The violin, let's say that this, for example, has a frequency of 440. So 440 is A. Now the violin in 440, its main peak, it is also in 440 frequency. So it's also an A, but it also has little peaks around, which are called harmonics. So that sign is not a pure sign anymore. It's not a perfect sinusoidal sign. It's a complex sign because it has, other things. The piano also has its main frequency with the same spacing, so 440, but it also has some harmonics here and there, and those harmonics make the piano sound like a piano. And the voice sounds like, and everybody's voice has different harmonics. So this is why we recognize sounds. So what I am showing to you right now is the time frequency data. So basically, if this is the time axis, this is the shape of the wave. But a mathematician called Fourier discovered that the complex signals, like these ones, all of them can be added using pure signals. So for example, this complex signal is just an addition of different pure signals here. So there is a way with the Fourier transform to transform the complex signals to divide them with pure signals. And that is also why we all get the frequency stuff. So, okay, I want to try to explain a bit clearly. Let's assume that this is a song. I don't know, whatever song, your favorite song. That wave can be separated in pure signals, and each signal has a different frequency. So the frequency data means which frequencies compose this signal. This is the time data, which is the sound, and this is the frequency data. But let's try to see it a bit better, because maybe if I show you, it will be. Actually, I forgot that I had this slide. But this is, for example, the time domain. This wave is composed of 3 different waves, and the frequencies and intensities of these different waves is the frequency domain. So this is better normally with visualizations, because you get like the bass, you get it in one side, which is the low frequency, and the high frequency sounds, you get it here. So you get like this dancing thing, whereas with the time domain, you just get a thing that doesn't look like anything. But we're gonna try to show you this. This hopefully will not have a demo effect this time, because I normally already did them. So if I go to my code pen, normally I did another one, which is called the oscillator visualization. No. Open it. Okay, so here I did what I kind of told you already. So we create our workshop. We create an oscillator that will create the sound, and we create an analyzer. The analyzer will look at it. Now, the rest of the code, I will not go like line by line, because you can find it in most places, but basically just configure a little bit the analyzer, you do the connections, and you create the array in which the data for the analyzer will be dumped. And I create the little thing, the canvas, the buttons, and here I'm going to ask the analyzer to get the frequency data. So the frequency data was the one that was in the left, the one that you see where the thing is. Now this is almost a pure signal, so let's try it. Wait, this thing has a bug. Sometimes I need to do one change and then it works. So for example, here we have a 440 signal, right? So we only get one peak in 440. We don't see the wave. We get like just one peak. And if I change the frequency, you will see that the frequency changes. Now, if I do the same thing, but instead of frequency, I ask the time domain data. This time, and I wait for it, this time I will see the wave. So now it's like a bigger wave, and now it's a very little wave. So these are the two domains that you see with the analyzer, kind of. But that gives you a lot of like creative possibilities, because like the very basic thing is using the frequency domain data to create some sort of, let's say, like an equalizer. So for example, here are the basses. This is like the hi-hat of the drum. Okay, we're gonna stop. How do we stop? So this is the same thing. I just loaded an MP3 song, and I set up an analyzer that goes through it, and just by requesting this frame animation with the frequency data, you get something that kind of dances. But you could go even further and do things like, for example, this one was, instead of doing bars, you can put it like with a Fibonacci sequence, like a flower, which is it's called a philotactic thing or something like that. And it's really cool because you can assign MP3. You can assign a frequency to each dot. So each dot is a different frequency of the song. Let's see. And I didn't know, but you get like this really funky like shapes, you know, which is quite interesting. Anyway, I'll stop now. And then little by little you start getting into this thing in which you, okay, so I have the frequency data. What else can I do with kind of those frequency data things? And you could even have 3 different buffered nodes with, for example, one with the bass, one with the drums, and one with the synthesizer. Pass it through different analyzer nodes and combine the 3 kind of different. So for example, I think I did something similar with this one. I can't remember. Wait, I'm going to open it with the normal editor. Again, I need to have one change for some reason. So for example, that's the drums. So the drums has one analyzer, that is the blue one, and then the bass has like the purple one. And the synthesizer has this one. So again, depending on how you arrange it, you can do a bunch of very cool things. So, by the way, as you can see here, I'm using a different library, which I will talk in a little bit, but the way I am loading these sounds is a little bit different than what I showed you before, but we will talk about that in a bit. So this is the analyzer part, but since we are kind of already talking a bit about the effects and stuff, I wanted to come back to my delay effect thing, in which, for example, you have, like I said, it becomes a little bit complicated to have something that is worthwhile, because you have like these very, very little building blocks of audio analysis and audio modification. And in order to do it like a proper effect, you need to start doing a lot of connections and graphs. So little by little, I started kind of refactoring those things out of my code. And I ended up creating a library called pizzicato.js that I wanted to show you. But the problem is that I created it like ages ago. I think I started doing it like 6 or 7 years ago, which in web audio terms is like prehistory. Because in that time, the implementations were starting a little bit. And I also like absolutely wanted 0 dependencies and like full cross-browser compatibility. So you see some horrible things like I don't know, it's like full of bars and semicolons and things like that. Not really, it's not modern JavaScript at all. But okay, it exists, and basically it has kind of a website which I wanted to show you really quickly. So normally I cannot remember the website. I think yeah. I hope. Yeah, okay. So, like I said before, when we create sounds, it's super annoying because every node, like an oscillator node that we create, gets destroyed when we use it, and it becomes like crazy. So I was super tired of having to create a new node every single time. So at the end, I decided to just like create a concept of the pizzicato sound. So the sound, the library will just create and dispose and garbage collect and all of the notes behind the scenes, and you just have to use it and do play and stop, and that's it. So basically you have like a, maybe if it works, maybe it doesn't want to work today, I'm sorry guys. Or maybe I'm in mute. I am in mute. So you have like the sound and you can stop it and start it as many times as you want, and you don't have to worry about stuff. So you just have like a play and a stop. Also, for example, to add, I didn't show you the horrible code that you need to do to load external files, but you need to load them, to decode them, to create the audio buffer node, to give the audio buffer node an array, the length of the sampling, and it's like a really this kind of annoying thing. So with this, you just say like, okay, I want this audio, and this is my success function, and that's it. And you with the browser, you can hear the sounds themselves. I will not do this because it will do like a loop and will hurt our ears, but you can also use your microphone. And you can also create your own function. So basically with JavaScript, you can tell JavaScript the frequencies and the sounds that you want. For example, this is a completely random thing, so it's white noise. But it's just the code that is adding this randomness inside each buffer of audio. And then what I did with the circle thing in which you have the different instruments is that you can do the concept of a group. So for example, if you have one track for the drums, one track for the guitar, and one track for the bass, you can create a group and do the things as if they were once one thing. So for example, you want to add an effect, or if you want to add another file or play them all together, instead of having to loop every time to play all of them, just do it one time, and you get like 3 different files that behave like one sound. But then the reason why I created this thing is it was more for the effects, but because every single effect was like this huge, humongous graph, and you get things like, for example, the delay that I showed you in the presentation, it's now this one. And you can, for example, you can have, this is the pure signal, and if you see the delay, and that was the thing that I wanted at the beginning, like to have an actual echo. And the delay node was just like pick, pick, and that's it. So you have to do this kind of feedback loop to have a proper echo. The ping pong delay is the same thing, but it goes from left to right to the two things. But I don't know if here we have to, anyway. You have, for example, distortion. Like if you have a guitar, which is kind of clean, you can add distortion, which is not great, but it kind of works. And here, for example, there are some researchers that looked at the plans of the original amplifiers of guitars from the 70s and the 80s, and they did them all again in web audio, and they sound really, really nice, and their algorithms are open, and the code is like in GitHub or something. It's really, really cool. Anyway, you have a bunch of effects. You have a reverb, for example, when I was talking about the multimedia stuff, like if you have a sound that is inside of a room, you can add a reverb as well. So like in a huge sound. And the thing is that you can also connect directly the individual nodes to the library. So if you want to add an analyzer, you can connect it directly to the library. You don't have, like, it doesn't prevent you from adding original nodes to the thing. So you could start this to simplify things, but then add whatever you want to add later, which is kind of handy. The filters are very interesting because actually I may have, sorry, really quickly, I'm gonna see if I still have it. I didn't plan this, so maybe it will be terrible, okay? But do you know how filters work? So they filter a certain frequency. And so if you have, for example, let's see, check. Okay. You have a sound. These are all the frequencies. And if you want to filter the frequencies, so now you have only the bass, basically. All of the high frequencies are not there anymore. And now you get all of the color again, and then you can also filter the low ones. And now you only get the high ones, for example. And you can see also here that they are kind of gone. So this is used with some of the nodes as well from web audio, but you can use it a bit easier with the low pass filters and the high pass filters. Maybe because I muted again. And then you just filter everything, and that's it. So anyway, this library still exists. It's still there. I haven't touched it in years, but now everybody tells me that Bologna in the summer is absolutely insufferable. So I was thinking that I'm gonna try to modernize it. I'm not sure I'm going to add any new effects yet, but there are several things that happened since I developed this. So for example, now Chrome and I think Firefox, some versions as well, you cannot start anything with web audio until the user has done a click to avoid like this spamming tabs in which you just open it and you get sound. So my library initializes automatically at the beginning, so that kind of blocks it, which is super annoying. So I need to add like a deferred initialization. I need to kind of modernize the JavaScript a little bit as well because it's not super great. And there were also some issues right now because the implementation for the audio input, like the microphone or if you plug in a guitar or something, they changed. So the code that I have right now, I mean, you can hear the thing when you plug in a guitar, for instance, but it's really horrible. Like we tried it with Ruben and it was absolutely terrible because now you need to play a little bit with the buffers and stuff, which I don't have. So this is kind of a project for the horrible months of summer. So if somebody wants to like dive in these things, let me know and we can do it together. Honestly, it's been such a long time that I don't remember very well. So don't be shy. Like we will both know nothing. And I am also very shy of my code. So we should totally check that. If you're interested, let me know. And in the meantime, this is my library now, and I want to do this. This is why I had to change one little thing in CodePen every time, is because that little change that I did in CodePen counts like a user input, and then it lets me do things. So I don't want to rely on those hacks anymore. So anyway, I have also a repository called Web Audio Resources under alemangui, in which I try to add nice tutorials, nice projects, nice things. So if you're interested, you could also take a look at that. And don't hesitate to like if you see, for example, if you start learning and you see a very nice tutorial or a video or something, you can do a pull request and I will be very happy to include it. And grazie mille.
Domande? Questions?
Sì. Sì, italiano va bene. Proverò.
I was wondering, it's a very basic question. Like, I want to know all these effects with the bar that go up and down, the visualization of the audio. You said it can be split between frequency, but how does it actually work? Does it count the amplitude in a certain amount of time to show the single bar, or how?
It's basically a mathematical formula called the Fourier transform. So Fourier, how do you write Fourier? Fourier transform. Well, actually, it's called the FFT. It's the fast Fourier transform, FFT, and it's a mathematical formula that has the input of the formula. This is probably not great. Yeah, the input of the formula is the function of the wave, and the output of the formula is the frequencies that it's composed. And it's magic. Like, honestly, it's one of my mysteries. I don't understand how Fourier got to this formula. It's insanely crazy. But it's just an implementation. Behind the scenes, you have all of the values, because it's a digital sound, so it's not continuous signal. It's like, it's bytes, ones and zeros. So you have all the points, and it takes that and does the FFT for them, and magically, we get these things.
There is a good video from on YouTube that explains the FFT.
Ah, really?
Twice and never understood about it.
Veritasium is super good, by the way, so maybe I should actually Veritasium FFT Fourier. Yeah, the fast Fourier transform, the most ingenious algorithm ever. And yes, it is quite crazy. So honestly, I recommend you just looking at it because it's mind-blowing. But that's what it does behind the scenes, yeah.
So I have a quick question, and mostly probably the same, but so it's possible for me it's magic to have a song and to separate different instrument and voice?
That is a very good question. So no, but
that software made now possible in my time when I made music 15 years ago, almost or 20 years ago. I can't.
There are some very, very impressive algorithms. So, okay, technically not, because, for example, if I have a guitar and I am singing, you get one waveform,
Yes.
and you separate it into basic frequencies. So it's very hard, since my voice has some harmonics and the guitar has some harmonics, it's very difficult to know which harmonics belong to whom. But with some AI and stuff and training models, some software, what they do is that they say, okay, normally the human voice has this kind of harmonics. And normally, for example, the bass guitars have this kind of harmonics. So when they do the FFT, they try to combine the basic frequencies until they get to an addition that has those harmonics. And they say, maybe this is the voice. But it's, okay, I have not seen one that is perfect, but I don't know, I haven't seen anything in like 7 years. So maybe now there are some that are very good. Because it's a bit, I have never seen it in the browser. Okay. It should be possible, but I have never seen it in the browser.
Now it's possible in like classic software. I don't know how, probably AI and stuff.
Yeah, most likely. So but it's like, for example, if you have the sound and you have 20 different bass signals, they do the permutation of all of them until they find something that looks like a voice. But it's super crazy. I honestly don't understand how they do it. It's super crazy. But like right now in a code pen, I could never do that.
Another question. You said that like an instrument has different harmonics,
Mm-hmm.
right? And you can split them with the web audio API, right?
You can see them. Yes.
You can split each individual harmonic.
You
right?
could.
Okay. So when you lay them back together, is it exactly the same sound, or is it different?
No, it's kind of, it should be the same because it's discrete. So honestly, I consider it simpler to work with discrete things than with continuous things. So you have like, for example, your buffer is, I don't know, 44 hertz, 44K hertz or something. So you have like the main peak and the different little harmonics. So you could like take one peak and remove it and then just add it again. But since you have like the exact same values, it should be fine. When it's like a continuous thing with, with electric stuff, it's a little bit more tricky because you never get the exact thing. But it's super difficult, yeah.
Another quick question. Someone uses your pizzicato jazz library.
Yeah.
Use cases that I'm curious about.
So yes, and I am actually scared about this because every week it has 1,700 downloads, which is too much from NPM, from someone that I have not touched for 5 years. So it's a little bit scary. And when I was preparing for the talk, I went to NPM and like, what the fuck? 1,700 downloads, and there was like a person who used it for a PhD thing in Canada, and there's like some applications that are made with that thing. But I did not like plan that at all. It was like a personal thing, and then it. So for example, if I am.
And now about Sneak in your NPM, Sneak, the security provider from NPM packages that have vulnerabilities in your.
Maybe there is a horrible vulnerability. Maybe I don't know. But like, okay, it has a bunch of contributors, but I don't know. Last time I touched it, it was 3 years ago. So as you can see, it's not super, like the last release was in 2018, but at some point I don't know, it kind of got some traction.
And nobody asked you for TypeScript support.
No.
No?
Actually, wait. For the little anecdote, at some point I was like, I am bored today, I'm going to add TypeScript. And holy crap, because the thing is that I needed to add the type definitions for the whole of web audio that I use. So after 2 hours, I was like, no, I'm not going to do this. Revert. I never checked again.
We can help you. Something.
Yeah, if you want, we can absolutely add this.
We have a super TypeScript guy.
Isn't it already typed the audio, the web
Probably.
interface should be already typed?
Probably today, yes. Probably today, yes. 4 years ago, not so much.
Is it possible to use the web audio API to return a WebRTC stream, something like change the my input from a microphone and apply some transformation and send the stream?
Yeah.
You can intercept the microphone before it send the microphone to the WebRTC. I'm not an expert.
No, that's, okay, let me see. So,
For example, the noise reduction in
Something like, for example, something like the blur background applied to the image. It's possible to
I think that, for example, zoom in the web
to distort your voice.
something like that.
to clean the noise.
Yeah, the noise filtering.
I think
Yeah.
they use.
So at some point, for example, I had this thing in which you distorted. So it was like a thing with the voice. So technically, you could say like, if that is your voice and you add effects to remove noise or to add noise or whatever, the remaining stream could be the input to your application. But I am thinking that you would have to code that yourself. Like you would have to say, the voice will first pass through this web audio graph, and then I will send it to the network. But I don't know if you can connect it to an existing application, like a third-party application. I don't know.
Because right now, if I'm not wrong, you are sending the audio output
To here.
to here. Yeah. But it's like sending a video stream to the video tagger to
Yeah.
intercept an audio video file. You can apply some transformation with the canvas and then send the canvas result to the video tagger.
I think you will need to create a virtual device on the laptop or whatever, and then connect that to the virtual device, and in the program you use, like OBS or something, you can select the virtual device.
That is probably an option. So for, with Linux, you have the possibility also of connecting audio between applications, but it's the same thing that you just said. It's just already baked in. But yeah, I think that would be the way.
That is that for like security concerns, they usually prevent going outside of the scope of your application. So maybe it's probably like creating your app for having video calls and then inside of it using web audio doing transformation.
Yeah, in which you code everything inside. That could work. Precisely, the security aspects is probably the thing that changed the most in the past years, and what broke the most my code, because because now everything is super.
Several years ago, Google created a very simple project to use sound to exchange data between devices. Something with ultrasound using something like you can send data between devices just with the microphone and the audio. Small bit, but
Like a modem. Yeah.
something like to authenticate something without internet information, to be sure that you are authenticated something near the device. So you can be sure that the device you send the application is near, something like that. But I think they dismiss this kind of approach for security reasons.
It doesn't surprise me.
And probably the fact that you have to click on one button to activate the audio context is
Yeah, it's also linked to that. For sure.
Questions?
Yeah.
Does it work on Internet Explorer?
No.
Una domanda qui?
It's a super simple question. I wanted to know about supported platforms and the possibility to extend it. Imagine I want to read files exported from a super old hardware.
Okay.
I have no more software.
So, okay, in terms of performance, it uses your machine's audio card. So if it depends on the machine you have, the performance it will have. But web audio performance is actually very, very performant. Since it's such a low-level thing, it doesn't pass through the let's say JavaScript. How do you call it? Like the virtual machine, the interpretation, the JavaScript interpretation engine. It's really in a separate thread, so it's very close to the metal. So in terms of performance, it's actually very, very good. But it will never be better than the machine you're running. So perhaps if I have like a super old machine with or a very bad audio card, and I try to do these super simulations with a gajillion things, at some point it will start choking. But let's say that I don't know how to respond, but it is as performant as can be. There is very little performance penalties on web audio side. It's very, very sleek. But yeah, your machine matters.
Question probably is also the pronunciation issue. The initial question was about file support.
The file support. The file support, it's a very good question. So, which I don't know the answer to before I try to I don't know. But there is, for example, if I come back to my code pen, and the one that actually I will not find it. So the thing is that you need to decode it. You have the file, you get the file data, like the binary data, and you need to decode it to have like the buffer thing. And the decoding depends on the codecs of your machine. So most machines have the basic codecs, AAC, MP3, all of the things. And basically, let's say that you have a file, whatever file format. If you can open it with your browser and it plays, then it's fine. If you can't, you're missing a codec. And if it's way too large, like I don't know, a 3 gigabyte sound file, probably it will choke, but more on the RAM aspect than on the codec aspect. So I don't know if that was a question, but it's like you need the RAM to be able to load the file, and you need the codecs to be able to decode it from its binary thing to the samples, let's say. But you can download the codecs eventually. Like for example, I know what is the Apple codec? I think it's AAC or something like that. Yeah. So like for a while, I think Windows did not have the AAC codec, so it was like a huge mess with iTunes songs, back in the prehistoric era of iTunes. So that kind of things still can happen.
For example, could be the WhatsApp audio codec.
Yeah.
I don't remember how his name, but is not. It doesn't happen so often to add the codec on your PC.
Yeah, that's actually an excellent. So if you go to your phone and to the files of your phone and you download the WhatsApp audio, very likely you will not have the codec on your computer to play it. Very likely. Yeah. Normally, yes, if they make it available. But then there's closed audio formats, so it's like a huge deal because you don't know how to decode them, and the classic. It's like video.
So files are loaded into memory, or the file is loaded into memory?
I am almost sure, but maybe that changed. I think it's loaded into memory and passed through a buffer, but I think it's loaded into memory. I think not, but I should come back to you on that one, because maybe yes.
Does it give you the chance to export? Okay, you cannot access the file system from browser, probably.
You can, no? You can access the file system.
With Chrome.
You can download a file system implementation.
Only with Chrome? That is a very good, I have never tried that. But that is a very, because you should.
You can make kind of web app where people can use a browser and Chrome
Yeah.
You can always download a file.
No, but for example, if you have the wave, you could save a WAV file, the WAV. I think that is the raw wave file. So if you have access to the file system, you should be able to just create a file with all of the frequencies and. That is a good addition to the library, for example. Yeah.
To ask you about video will see.
Yes.
I think he does all by software with no codec machine.
Yeah, that thing is crazy. Yeah, but I think it includes the codecs inside of the binary, no? VLC. Normally, I suppose.
Probably, yes.
Yeah.
And I'm wondering how WhatsApp web works with
With WhatsApp web, yeah.
audio.
Probably it is possible to use the WebAssembly as decoder encoder. But it might be possible to handle some stream as well.
I don't know.
I don't know. I don't remember the possibility to use the BTS plugin from
Oh yeah.
a desktop program inside of probably some crazy lessons.
Very hacky.
Very hacky.
I was thinking about use VLC as a service. I give you a file, give VLC a file, and it takes me back the wave or MP3 or whatever.
Yeah, but yeah, like a transformation, a format transformation. But
So you can use, for example, FFmpeg
mhm.
in the browser directly with WebAssembly, this is the WebAssembly version. So you can send an input and get an output, but of course you cannot use it in a stream. So you cannot apply live transformation.
Yeah, no, you cannot.
Because you have to use the FFmpeg version that is not available with WebAssembly. But probably
Okay.
because they are using WebAssembly for the video game.
Yeah.
Real time, so probably it's possible.
I have never tried it, but it should be. It should be possible. Another item to to do this summer.
It's possible for the canvas, maybe it's possible also for the.
Yeah. It is possible for the canvas?
Yeah, because
Oh yeah, with the video games.
games work
Yeah.
with the canvas.
Yeah.
Okay. Thank you, Alejandro.
Thank you very much.
Really interesting talk. We can switch back to Italian. Veramente molto interessante, mi ha colpito molto. Diretta è finita. È un peccato che non abbiamo fatto, diciamo, la gente di sempre, perché se hai smesso di registrare, questo volevo dire.